Hi guys, at the end of our last video, we talked about breaking up a full equation into two half equations. We'll now look at how we can work the other way round and construct the full equations again if we know the half equations. So let's see how to do this with the example of copper and concentrated nitric acid reacting to give us nitrogen dioxide. So if we're provided with the two half equations here, we can see copper is losing 2 electrons to become Cu2+, so this is oxidation. Remember, oxidation is loss. That's the oil in our mnemonic that we learned in the last part of the video. Then we have NO3- reacting with 2 H+ ions and an electron to become NO2 and H2O. Because electrons are being recombined here with the oxygen in particular, remember reduction is gain, so what we have here is a reduction reaction. To be able to recombine two half equations, we must balance the electrons for each equation. We can see here we've got 2 being released from the copper, but only 1 being taken in by the NO3- part of the reaction. We multiply everything in this second line by 2. So that's what we've done when we look at this step here. And you can see we've got 2 NO3-, 4 H+, combining with 2 electrons to give us 2 of each of the products. We then combine the 2 equations we have above. So that's just a case of writing all of the left-hand sides together here in one equation, and all of the right-hand sides together in one equation. To give us our final full reaction equation we want, we just have to cancel things that appear on both sides. In this case, that's only the electrons that we cancel off, and then this gives us our final equation for these half reactions of 2 NO3-, 4 H+ reacting with copper, which is a solid metal, to give us copper 2+ ions, 2 NO2 and 2 H2O. We're soon going to see that another way to put together full reactions equations is using oxidation numbers for the species. You should remember from last year that different species have different tendencies to form particular ions, and therefore have particular oxidation numbers. Let's look through a few of these common trends. So elements in their standard state, as they appear, usually have an oxidation number of 0. Metals tend to become oxidized, so we can separate.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today and together let's make A-level chemistry a walk in the park.